In this video, we will discuss about simplification of 8 logarithmic problem. 1. Simplify logarithm of x cubed y squared to the base a minus logarithm of x squared z over y the power of 3 to the base a plus 2 times logarithm of radical z to the base a. Step 1. Apply logarithmic property. For example, logarithm of xy to the base a is equal to logarithm of x to the base a plus logarithm of y to the base a, and power rule, logarithm of x the power of k to the base a is equal to k times logarithm of x to the base a. When we expand the first term, we get logarithm of x cubed to the base a plus logarithm of y squared to the base a. Again, by using power rule, we get 3 times logarithm of x to the base a plus 2 times logarithm of y to the base a. When we expand the second term, we get, by applying product law, logarithm of x squared to the base a plus logarithm of z to the base a, and applying quotient rule, we get minus logarithm of y cubed to the base a, and applying power rule, we get 2 times logarithm of x to the base a plus logarithm of z to the base a minus 3 times logarithm of y to the base a. When we expand 2 times logarithm of radical z to the base a, first change this radical into exponent forms, so this becomes 2 times logarithm of z to the power of 1 over 2 to the base a. By applying power rule, it becomes 2 times 1 over 2 logarithm of z to the base a, which is equal to logarithm of z to the base a. Combine the term, we get 3 times logarithm of x to the base a plus 2 times logarithm of y to the base a minus 2 times logarithm of x to the base a plus logarithm of z to the base a minus 3 times logarithm of y to the base a plus logarithm of z to the base a. When we combine like terms, we get 3 minus 2, we get logarithm of x to the base a, and 2 plus 3 become 5 logarithm of y to the base a, and this will be cancelled out. So the final answer is logarithm of x to the base a plus 5 times logarithm of y to the base a. This is a simplified answer. Welcome to my YouTube channel. I'm Gazahi. If you are new to the channel, please subscribe to get more video and hit the bell icon to get all notification. Please watch full video. Let's continue. 2. Simplify logarithm of x to the power of 7 over y cubed to the base a plus 2 times logarithm of radical y over z to the base a minus logarithm of x squared z to the power of 4 to the base a over logarithm of x over z squared to the base a. Step 1. By using quotient rule, we get logarithm of x to the power of 7 to the base a minus logarithm of y cubed to the base a. Again, by using power rule, we get 7 times logarithm of x to the base a minus 3 times logarithm of y to the base a. When we expand logarithm of radical y over z to the base a, by using quotient rule, logarithm of radical y to the base a minus logarithm of z to the base a. When we change this radical into exponent, it becomes y the power of 1 over 2, and again by using a power rule, it becomes 1 over 2 logarithm of y to the base a minus logarithm of z to the base a, and multiplying by 2, we get logarithm of y to the base a minus 2 times logarithm of z to the base a. When we expand logarithm of x squared z the power of 4 to the base a over logarithm of x over z squared to the base a. When we expand numerator first, by using product rule, we get logarithm of x squared to the base a plus logarithm of z the power of 4 to the base a. Again, by applying power rule, we get 2 times logarithm of x to the base a plus 4 times logarithm of z to the base a. When we expand the denominator, we get logarithm of x to the base a minus logarithm of z squared to the base a is equal to, by applying power rule, logarithm of x to the base a minus 2 times logarithm of z to the base a. When we combine numerator and denominator, we get 2 times logarithm of x to the base a plus 4 times logarithm of z to the base a over logarithm of x to the base a minus 2 times logarithm of z to the base a. When we combine all terms, and this minus 3 logarithm of y to the base a plus logarithm of y to the base a becomes minus 2 logarithm of y to the base a. So the final answer is 7 logarithm of x to base a minus 2 times logarithm of y to the base a minus 2 times logarithm of z to the base a minus 2 times logarithm of x to the base a plus 4 times logarithm of z to the base a over logarithm of x to the base a minus 2 times logarithm of z to the base a. This expression can be left in its simplified form or evaluated further depending on specific values. 3. Simplify logarithm of x to the power of 5 to the base a plus logarithm of y cubed to the base a minus 3 times logarithm of z to the base a over logarithm of x square z to the base a minus logarithm of y square over x cube z to the base a. By applying power rule, the numerator becomes 5 times logarithm of x to the base a plus 3 times logarithm of y to the base a minus logarithm of z is the power of 3 to the base a. When we simplify the denominator, we get by product rule logarithm of x square to the base a plus logarithm of z to the base a. By applying power rule, it becomes 2 times logarithm of x to the base a plus logarithm of z to the base a. Combine numerator and denominator, we get this one. When we expand logarithm of y square over x cube z to the base a, by quotient rule we get logarithm of y square to the base a minus logarithm of x cube z to the base a, and by product rule we get this one, logarithm of x cube to the base a plus logarithm of z to the base a. So logarithm of y square over x cube z to the base a becomes logarithm of y square to the base a minus logarithm of x cube to the base a minus logarithm of z to the base a. Again, by applying power rule we get 2 times logarithm of y to the base a minus 3 times logarithm of x to the base a minus logarithm of z to the base a. When we combine the terms, we get the final answer is 5 times logarithm of x to the base a plus 3 times logarithm of y to the base a minus logarithm of z to the power of 3 to the base a over 2 times logarithm of x to the base a plus logarithm of z to the base a minus 2 logarithm of y to the base a plus 3 times logarithm of x to the base a plus logarithm of z to the base a. This expression can only be simplified further if there are numeric value or specific constraint on x, y, and z. 4. Simplify logarithm of x to the power of 4, y to the power of 2, z to the base a minus logarithm of x square over y to the base a over logarithm of x square y to the power of 4 to the base a plus logarithm of z square over x cube y to the base a. Step 1. Simplify the numerator of the first term. Expand each term. When we simplify this by product rule, we get logarithm of x to the power of 4 to the base a plus logarithm of y square to the base a plus logarithm of z to the base a. Again, by power rule, we get 4 times logarithm of x to the base a plus 2 times logarithm of y to the base a plus logarithm of z to the base a. When we expand this by using quotient rule, we get logarithm of x cubed to the base a minus logarithm of y to the base a. And again, by using power rule for this one, we get 2 times logarithm of x to the base a minus logarithm of y to the base a. 4 minus 2, we get 2 times logarithm of x to the base a. 2 minus of minus, so we get 3 times logarithm of y to the base a plus logarithm of z to the base a. Simplified denominator of the first term. When we simplify this by product law, we get logarithm of x square to the base a plus logarithm of y square to the base a is equal to 2 times logarithm of x to the base a plus 4 times logarithm of y to the base a. Combine the simplified numerator and denominator, we get this one. When you simplify logarithm of z is the power of 2 over x cube y to the base a by using quotient rule, logarithm of z squared to the base a minus logarithm of x cube y to the base a. We get logarithm of z squared to the base a minus logarithm of x cubed to the base a minus logarithm of y to the base a. Again, by using power rule, this becomes 2 times logarithm of z to the base a minus 3 times logarithm of x to the base a minus logarithm of y to the base a. Combine the terms and add the simplified fraction in the second term. We get 2 times logarithm of x to the base a plus 3 times logarithm of y to the base a plus logarithm of z to the base a over 2 times logarithm of x to the base a plus 4 times logarithm of y to the base a plus 2 times logarithm of z to the base a minus 3 times logarithm of x to the base a minus logarithm of y to the base a. This is the final simplified form. Further reduction depend on specific constraint or values. 5. Simplify logarithm of 32 to the base 2 minus logarithm of 27 to the base 3 plus logarithm of 125 to the base 5 over logarithm of 64 to the base 2 plus logarithm of 16 to the base 4. We simplify this logarithm expression by using power rule. Logarithm of a the power of k to the base a is k times logarithm of a to the base a, and this value becomes k. Since logarithm of a to the base a is 1, so logarithm of 32 to the base 2 is equal to 5, since 32 is to the power of 5, and logarithm of 27 to the base 3 is equal to 3, since 27 is equal to 3 to the power of 3. Logarithm of 125 to the base 5 is equal to 3, since 125 is equal to 5 to the power of 3. Logarithm of 64 to the base 2 is equal to 6, since 64 is equal to the power of 6. Logarithm of 16 to the base 4 is equal to 2, since 16 is equal to 4 to the power of 2. Then substitute the value, we get 5 minus 3 plus 3 over 6 plus 2, which is equal to, we get 5 over 6 plus 2, and when we simplify, we get 17 over 6. Simplify logarithm of 81 to the base 3 minus logarithm of 16 to the base 2 plus logarithm of 256 to the base 4 over logarithm of 25 to the base 5. Logarithm of 81 to the base 3 is 4, since 81 equal to 3 to the power of 4. Logarithm of 16 to the base 2 is 4, since 16 is equal to the power of 4. Logarithm of 256 to the base 4 equal to 4, since 256 is equal to 4 to the power of 4. Logarithm of 25 to the base 5 equal to 2, since 25 equal to 5 to the power of 2. Then substitute the value, we get 4 minus 4 plus 4 over 2, what we get 0 plus 2, so the answer is 2. 7. Simplify logarithm of 32 to the base 2 plus logarithm of 9 to the base 3 over logarithm of 16 to the base 4 minus logarithm of 125 to the base 5 over logarithm of 8 to the base 2. Logarithm of 32 to the base 2 is equal to 5, since 32 is equal to the power of 5. Logarithm of 9 to the base 3 is equal to 2, since 9 equal to 3 is the power of 2. Logarithm of 16 to the base 4 is equal to 2, since 60 is equal to 4 to the power of 2. Logarithm of 125 to the base 5 equal to 3, since 125 is equal to 5 to the power of 3. Logarithm of 8 to the base 2 is equal to 3, since 8 is equal to the power of 3. Then substitute the value, we get 5 plus 2 over 2 minus 3 over 3, which is equal to 7 over 2 minus 1. So the answer is 5 over 2. 8. Simplify logarithm of 128 to the base 2 minus logarithm of 27 to the base 3 plus logarithm of 25 to the base 5 over logarithm of 64 to the base 2 minus logarithm of 256 to the base 4 over logarithm of 16 to the base 2. Logarithm of 128 to the base 2 is 7, since 128 is equal to the power of 7. Logarithm of 27 to the base 3 is equal to 3, since 27 is equal to 3 is the power of 3. Logarithm of 25 to the base 5 is equal to 2, since 25 is equal to 5 is the power of 2. Logarithm of 64 to the base 2 is equal to 6, since 64 is equal to the power of 6. Logarithm of 256 to the base 4 is equal to 4, since 256 is equal to 4 to the power of 4. Logarithm of 16 to the base 2 is equal to 4, since 16 is equal to the power of 4. Then substitute the value, we get 7 minus 3 plus 2 over 6 minus 4 over 4 is equal to 6 over 6 minus 1. 6 over 6 is 1, 1 minus 1, 0. So the answer is 0. This is all about simplification of logarithmic problem.
If there is any doubt, question, comment, don't hesitate to leave under comment section. If you enjoyed this video, I hope you get some value from it. Please hit the like, share, subscribe and bell button to get all notifications. Thank you so much for watching. I will see you with another video.